So our P of t function, if r is 0.06 and n is 4, that's what we did previously, then P of t is going to be 1 plus 0.06 over 4 raised to the 4t times p sub 0. And of course that simplifies, so P of t equals 1 plus 0.015 to the 4t times p sub 0. And if p sub 0 happens to be $10,000, that agrees with what we got originally. Now if we have a different interest rate, let's say 5% interest for, and if we compound monthly, that would be 12 times a year. Then your P of t equals 1 plus 0.05 over 12 raised to the 12t times p naught. Okay, because of course our n is 12, so we're going to have a 12 here, and we're going to have a 12 here. Our rate is 0.05, 5%, so we're going to have a 0.05 here. And then whatever we invest, this will tell us how much we have at the end of that time. Now, the form of this function is P of t equals p naught times b to the t, where and actually it's not b to the t, it's b to the nt, where b equals 1 plus r over n. Okay? For r equals 0.05 and n equals 12, b is 1 plus 0.05 over 12. Which is, of course, then 1.00416 repeating. Well, this is just an exponential function, isn't it? This is an exponential function with base b equals this. And this is going to allow us to solve equations involving this function. For example, if we want to know when P of t takes a certain value, well, we're going to set this expression equal to that value. Okay? So now we're going to have some number raised to a power equals that value, and the t that we're looking for is in the exponent. So we're going to have to isolate the b to the 12t. That'll be equal to something. And then we're going to convert to logarithmic form and easily solve the equation. Now that's coming up, but it'll be to your advantage if you have this sort of in mind when we do.